Hello everyone, welcome back. So this is the second video where we are going to discuss symmetry elements in crystals. So in the first video, we have seen the PYQs that has been asked in the civil services mains examination and also in the forest service examination regarding crystal systems. So what type of questions have appeared in the crystal systems we have seen. So they have asked, for example, in isometric system, write the symmetry elements of the formal class and give examples of some minerals with their chemical formula. Now to answer such questions, first you have to understand what are the symmetry elements in the crystals. So in this video and also in the next video, we will discuss the basic symmetry elements of the crystals. Okay, so in this video we will start with the definition of what is a crystal, and then we will look at what is unit cell, what is crystal lattice, and then we will see what are the different types of unit cells that are present in the different crystal systems: primitive cells, face centered, body centered. So after looking at them, then we will start with the symmetry elements. Okay, plane of symmetry, center of symmetry. Okay, mm, mirror symmetry. So we'll look into those symmetry elements, rotation symmetry. So we'll look into those elements afterwards. Okay, first we will start with the basic definitions. Now you need to have basic idea of these symmetry elements to answer the questions from crystal systems. Okay, so this video and the next video will help you do that. All right, so first we will start with definition of a crystal. So what is a crystal? Okay, so a crystal may be defined as a solid polyhedral form of a substance, so basically inorganic substance, because minerals are inorganic substances. So crystal is defined as a solid polyhedral form of a substance bounded by smooth geometrical surfaces which are called as faces. So crystals have smooth geometrical surfaces, they are called as faces. So there exists a definite relationship between different faces of a crystal. Okay, so crystals result because of, so crystals they result because of orderly arrangement and perfect internal arrangement of atoms of elements or compounds during the cooling phase. So this cooling phase is called as crystallization. So in crystals there is an orderly and definite and orderly arrangement of atoms of elements. Okay, so this cooling process is known as crystallization. Now, so basically the form of a crystal, the outward manifestation, so how the crystal appears outwards, is because of the orderly arrangement of atoms inside the crystal. So जो इंटरनल अरेंजमेंट ऑफ एटम्स है वही उसको शेप या फॉर्म देते हैं. Okay, now let us proceed and look at definitions of unit cell and crystal lattice. So a unit cell is basic building block. It is a basic building block that repeats over and over again in all directions in crystalline solids. So basically unit cell is the basic unit. Now, so suppose this is your unit cell, this is your unit cell. Okay, here it is your unit cell, this is your unit cell, this is your unit cell. Let me use another color. So this is your unit cell, this is your unit cell. Okay, so this is the basic building block which repeats over and over again in all directions in a crystalline solid. Now, what is a crystal lattice then? So crystal lattice is geometrical arrangement of points on which unit cells are arranged. So these points, so in the diagrams you can see there are points. So these points. So geometrical pattern of points on which the unit cells are arranged. So these points, they are your crystal lattice. So unit cell is arranged on these crystal lattice. Now, what is the difference? So here you can see clear cut difference between unit cell and crystal lattice. So the arrangement, so these are the points, the arrangement of atoms. Okay, they are orderly arranged. So this entire network, it is your crystal lattice, whereas the unit cell is the smallest unit. This is the basic unit. The basic unit is the unit cell. Okay, unit cell will repeat itself in all directions within the crystal lattice. So here is the diagram of unit cell. Now this unit cell has A, B, C axis. Now we have seen in the first video there is a relationship between crystallographic axis in different crystal systems, right? So in case of cubic system or isometric system, we have A is equal to B is equal to C. All the three axes are of same length. That is not true with the tetragonal system, where A is equal to B but it is not equal to C, right? One of the axes is longer. So there exists a relationship between these axes, and these three axes, they also have definite angle between them. So alpha, beta and gamma are the angles between these three axes. Okay, so unit cell का जो dimensions हैं, they are A, B and C. So in case of isometric system, we have seen this, all the three axes are of same length, and alpha is equal to beta is equal to gamma, that is 90 degrees, and all of them are perpendicular with each other. So in the isometric system, this is the case. There is a relationship between the axis, length of the axis, and also the angle between them. So alpha, beta and gamma are the angle between these three axes. Now here is an example of orthorhombic system. So unit cells, so different type of unit cells within orthorhombic system. So here in the orthorhombic system, you can see alpha, beta and gamma, it is equal to 90 degrees. Alpha is equal to beta is equal to gamma, it is equal to 90 degrees. And A is not equal to B is not equal to C. That means all the three axes are of different length. So A is not equal to B is not equal to C. All the three axes A, B, C, they are of different length in the unit cell. So these are the different type of unit cells in the orthorhombic system. So this is an example of different type of unit cell. So a unit cell which has atoms only at the corners. So ये पहले वाला जो है ना simple. So this is also called as primitive type. इसको primitive type भी बोलते हैं. This is also known as primitive type. So here atoms are present only at the corners. Then we have face centered, यानी तुम्हारे जो क्रिस्टल के फेसेस हैं उसके सेंटर में है. So यहाँ देखो टॉप फेस पे के सेंटर में है, ये साइड फेस के सेंटर में है. Here it is body centered, center of the lattice, and it is end centered. So end जो फेसेस हैं, जो टॉप एंड बॉटम, उसके सेंटर में तुम्हारा एटम है. So different types of unit cells are there. So here in this table you can see different types of unit cells present in different systems. So for example, in cubic system you will find primitive types, okay, only at the corners. Body centered also, you will see body centered unit cells, and also face centered unit cells. And the examples of minerals which crystallize under this particular system, that is potassium chloride and sodium chloride. So these are the relationship between the axis length. This is the angle between the axis. So here is the compilation, the entire table, where you have the length of the axis, the angle between the axes A, B and C, and what type of primitive or what type of unit cells are present in these crystal systems and examples, right? So this table has all. Now, diagrammatic representation of the types of unit cells, different types. So you can see here in the cubic system or isometric system, you have simple or primitive type. Primitive type में you have atoms at the corners of the unit cell. Atoms corners में है, unit cell के corners में है. Okay. In case of face centered, so faces के center में है, along with the corners, atom is also present at the center of the face. Here, along with the corners, atom is present at the center of the body. Same in the monoclinic, we have simple, that is primitive. We have also end faced, यानी जो top and bottom है, उसके center में तुम्हारा atom है. Likewise in different crystal systems. So this is the diagrammatic representation of different unit cells that are possible in different crystal systems. All right. So next is we are looking into elements of a crystal. So first element is crystal face. So here you see any crystal will have one or more type of external surface that may be regular or modified geometrical figure, such as a square or a rectangle or a polygon, right? So these smooth geometrical surfaces, they are called as faces. Okay, a given number of similar faces on a crystal, when studied together, it makes a form. So crystal form हम लोग जब बोलते हैं ना, what do you mean by form? Is the shape of the crystal. क्रिस्टल का शेप कैसा है? पिरामिडिक है, प्रिज्मेटिक है, कैसा है शेप उसका? ओके, सो पिनेकॉइड है. व्हाट इज द शेप ऑफ द crystal? So a given number of similar faces on a crystal, when they are studied together, it makes the form of a crystal. Okay, the shape of a crystal. Now between these faces there exists definite relationship. Okay, so there are always a number of faces on a crystal, multiple faces are there on a crystal, and the angle at which two adjacent faces are placed on a crystal with respect to each other is called as interfacial angle. यानी दो faces के बीच में जो angle है, the two faces they make an angle with each other, so that is called as interfacial angle. To measure interfacial angle we have goniometer. So the instrument that is used to measure the interfacial angle or the angle between the two faces, adjacent faces, is called as interfacial angle. For example, here in the diagram we have a crystal, and here there are two faces. This is one face. Okay, this is one face, and this is second face. First face and this is second face, right? Now we are trying to find out the angle between the two faces. Now the way we do that is we draw the pole to the faces. हम लोग directly measure नहीं करते हैं. What we do is we draw the pole to the faces. Pole is normal or 90 degrees to the face. Pole is 90 degrees. So pole of the face means from the face 90 degrees. So here you can see this is one face, right? From here we are drawing a line which is at 90 degrees from this particular face, pole of the face. Here also second face. So from here also we are drawing a line which is 90 degrees to the face, and the point at which they intersect will measure the angle. So it is 40 degrees. So the way we measure the interfacial angle is we draw the poles to the face, yani 90 degrees to the faces, and the point at which they intersect or they meet, we measure the angle. That is interfacial angle. Okay, now symmetry of a crystal. So by symmetry it means there is some regularity in the arrangement of faces. What do you mean by symmetry elements? ये जो faces हैं, there is a regularity in the arrangement of these faces in the crystals, so that is the symmetry. Okay, nature में symmetry है. In nature symmetry occurs. Now for example, we are bilaterally symmetrical animals. If you cut human from the center, our left hand side will be exact mirror image of the right hand side. We are bilaterally symmetrical. There are organisms which are radially symmetrical. Okay, so symmetry occurs in nature. So symmetry means there is some regularity in the arrangement of the faces on the crystal. Okay, so by crystal symmetry, what do you understand by this particular term? So there is a sort of regularity in the arrangement of faces on the body of a crystal. So we are trying to understand this regularity, repetition. Okay, so for instance, if a crystal could be cut into two halves, one half being the mirror image of the other half, so there is symmetry. So there is a plane which can divide the crystal exactly into two halves. So there is some symmetry here, right? So what are these regularities or symmetry elements? So plane of symmetry, axis of symmetry, center of symmetry. So these are the different symmetry elements. So in this video we will be restricting ourselves to plane of symmetry. Axis of symmetry and center of symmetry we will discuss later. Okay, so coming to plane of symmetry, right? So what do you mean by this plane of symmetry? So any imaginary plane, कोई भी एक plane imagine कर लो within the crystal. So within the unit cell, basically within the unit cell you imagine any plane, okay, passing through the center. Plane should pass through the center. So any imaginary plane which is passing through the center of a crystal in such a way that it divides the crystal into two exact halves. वो crystal को दो exact half में divide करता है. Then we say that there is plane of symmetry. So any imaginary plane passing through the center of a crystal in such a way that it divides the crystal into two exact halves, then it is called as plane of symmetry. So in other words, a plane of symmetry is said to exist in a crystal when each face, each edge or solid angle, that is the corner. Solid angle means इस corner की बात कर रहे हैं. We are talking about this corner. Solid angles are corners, right? So for every face, every edge, every solid angle, there is another similar face, edge or solid angle occupying the identical position on the opposite side. एक तरफ अगर if you have a face or edge or solid angle on one side, the exact on the opposite side you will have exact edge, face and corner or your solid angle. Then you have a plane of symmetry. Okay, so this imaginary plane should pass through the center and divide the unit cell into two exact halves. Then mirror symmetry. Okay, this is the last element that we are going to discuss here. Axis of symmetry we'll discuss in the next session. Okay, so mirror symmetry. Now it is not exactly same as plane of symmetry. So mirror symmetry operation is an imaginary operation that can be performed to reproduce an object. For example, what do you mean by mirror symmetry is you cut an object from the center. So यहाँ पर ये example है तुम्हारा, इसको तुमने center से cut किया. You have cut it from the center. Okay. Now, if you place a mirror here, अगर यहाँ पर तुम एक mirror place करते हो ना, so the image which is produced in the mirror, it should reproduce the rest half. जो बाकी का हाफ कट कर दिया तुमने, कट करके उस वहां पर एक मिरर लगा दिया. So you have cut an object in exact half and you have placed a mirror. So the image that is formed in the mirror should reproduce the half, rest of the half. So the operation is, sorry, Okay, so the operation is done by imagining that you cut an object in half. So यहाँ पर भी देख लो, ये वाला तुमने यहाँ पर हाफ एग्जैक्टली बीच से कट कर दिया एंड यहाँ पर एक मिरर प्लेस कर दिया. So the image that is formed in the mirror should complete this rest of the half. वो बाकी हाफ को कंप्लीट करना चाहिए, right? So operation is done by imagining that you cut an object in half, then place a mirror next to the one half that is present. The reflection in the mirror, if the reflection in the mirror reproduces the other half, then the object is said to have mirror symmetry. तो यहां पर इन दोनों केसेस में यू हैव मिरर सिमेट्री. इन द फर्स्ट टू केसेस, ये पहला और सेकंड दोनों केसेस में यू हैव मिरर सिमेट्री बिकॉज व्हेन यू प्लेस ए मिरर एट द सेंटर you get the exact half. The rest, the mirror, the image which is produced in the mirror, it reproduces the rest half. But in this case, third case में देखो यहाँ पर, so you have, तुमने diagonally cut किया है. So when you cut it diagonally and place a mirror here, यहाँ पर एक mirror तुमने place किया, the image that is produced, it is not the exact half, right? So the plane of a mirror is an element of symmetry referred to as mirror plane. उसका सिंबल m होता है. तो ये थर्ड केस में तुमको देखो ओरिजिनल जो शेप है वो नहीं मिल रहा है. द इमेज, the reflection in the mirror, it produces a complete different object from the original one. ये ओरिजिनल ऑब्जेक्ट को रिप्रोड्यूस नहीं कर रहा है मिरर इमेज. इट इज प्रोड्यूसिंग समथिंग डिफरेंट फ्रॉम द ओरिजिनल इमेज. सो इट डज नॉट हैव, सो डायगोनल प्लेन में ये वाला जो प्लेन है ना, इट डज नॉट हैव मिरर सिमेट्री. ये वाला प्लेन होता, इफ इट वाज हॉरिजॉन्टल प्लेन, इट माइट हैव, हॉरिजॉन्टल प्लेन में होता या फिर वर्टिकल प्लेन में होता, लेकिन डायगोनल प्लेन में तो मिरर सिमेट्री नहीं है. ओके, सो दैट इज मिरर सिमेट्री. So these are some of the symmetry elements. So we'll continue with the symmetry elements in the next video also. There we will discuss about the rotation symmetry. Okay, so other symmetry elements we will discuss later. So that will be all from this video. Thank you very much.